All right, example 1 today. We're graphing rational functions, identifying some key components. Of course, asymptotes we've been talking about. And so we're going to also just state the domain and range. That's not new to us. Domain, right? All the x values, range, all the y values that this function could give us. So let's go ahead and knock this guy out. So let's go ahead and identify the asymptotes right off the bat. So horizontal asymptotes, notice the degree of the top and the bottom is the same. So if that's the case, you just divide the leading coefficients. So we have a horizontal asymptote at y equals 3. So let me go ahead and sketch that in. So y equals 3, I'm going to turn my paper. And remember, we just mark these as dashed lines, or dotted, however you want to describe them. So through y equals 3, there is a horizontal asymptote. Okay. How about vertical? Well, of course, vertical comes from the denominator, anywhere that it would equal 0. And so we've got a vertical at x equals 2, because if we plug 2 in there, our function would be undefined. So let's make that one over here, x equals 2. Again, same thing, just a dashed line there. Kind of mark that in so we can see it. Okay, how about a couple key points here? So intercepts, right? Those are nice places to start. So you're going to get an x-intercept where the top equals 0. So if we solve that, 3x plus 2 equals 0. So subtract your 2, divide your 3, so negative 2/3. So about in here, we're going to get an x-intercept. Y-intercept, where it crosses the y-axis, of course that happens, you just plug 0 in for your x's. So if I plug 0 in there, those would go away, and I'm going to get, what, negative 1? So we've got a y-intercept right there. Those are the only intercepts for this one. And now we just need a few points so we can plug, get enough to kind of sketch things in. Now, honestly, I would just go to my calculator to help me with that. And so let me put this up here on the screen. Maybe we can see it. So I've already plugged it in. And, of course, you could just go type graph and kind of see what it looks like. We've got a fill there. But let's go to our table and just pull a couple nice values off, okay, that I can put on my graph. Let me put this over here where we can see this. So let's see what we've got. So like at negative 6, my value is 2. I don't know if that showed up very good, but negative 6, my value is 2. Hey, and I could put, there's some points in between. In fact, let's go. What's it at 1? It's negative 5. So let me maybe plot that in. And again, just kind of sketch this. Something like that, okay, and that's what we see on our screen. Now we've got stuff going on up here as well. So let me go pull just a couple values off. That's all we need. So at x equals 3, my value is 11. So that's actually up here off my grid just a little bit. At 4, it's 7. So let me mark that. At 6, it's 5. I'm just looking for nice integers here. There's fractions in between. And honestly, that's probably enough. Let's see if we get anything else out here. 8, it is what? 4 1/3. So it's just in here maybe. So let me just kind of sketch that. Okay. We've got something like that. Now, one last thing that I want to go ahead and put in here. It says state the domain and range. And you're going to do that on the assignment as well. Okay. Now, that should be pretty easy. It's tied to these asymptotes. So what is my domain? What is my domain? Well, it's everything except x equals 2, right? It covers every other x value. And so let's list that interval notation. So that's going to be -infinity up to 2 union 2 to infinity. So there's our domain, everything except x equals 2. How about our range? Kind of a similar deal. In this case, our horizontal asymptote, so it's everything except y equals 3. So we've got negative infinity up to 3, union 3 to infinity. Okay?